space travel inevitably confronts us with one massive, inescapable challenge that must be solved: securing sufficient energy, essentially, the proper fuel, to arrive at our intended destination. Science fiction narratives consistently introduce fictional mechanisms to circumvent this energy challenge, such as warp cores and hyperdrives, among others. However, that's precisely why we categorize it as science fiction. These technologies remain absent from our present-day reality. And although scientific breakthroughs might revolutionize the field, such advances aren't approaching within our generation. Yet this doesn't definitively mean humanity will never witness a vessel journey between our galaxy's distant stars. It simply indicates we must discover an alternative method for powering such vessels. And the most promising starting point actually lies deep within our own past. Throughout most of human history, we journeyed by watercraft using wooden oars driven by human muscle or fabric sails propelled by wind currents. Sailing vessels carried no combustible fuel, yet they traversed enormous distances by capturing nature's forces. Even in modern times, sailboats glide across waterways and seas, moving without motors, directed exclusively by air currents. Now, what if we could implement this identical concept in space? Before pursuing that, let's examine more closely how sailing actually functions, because the forces propelling boats through water may unveil something unexpected about propulsion beyond our planet. Consider this question: what propels a sailboat? The response appears self-evident, correct? It's the wind. But where does wind truly originate? You see, wind results from temperature variations. Certain regions of Earth warm up while others stay shadowed. Warm air expands and ascends while cool, heavy air shifts inward to occupy the emptiness. This circulation generates what we experience as wind, and fueling this entire mechanism is the sun, the driver of all weather patterns and natural phenomena on Earth. So in a genuine sense, sailboats are effectively solar-driven. For millennia, sails enabled humanity to traverse the mighty oceans. But even our grandest maritime expeditions seem insignificant compared to the limitless void extending beyond our world. The sea is immense, but space stretches infinitely, a complete vacuum where nothing exerts force, attracts, or moves without intention. So, how do we navigate through it effectively? Our existing rockets are fundamentally too sluggish and too wasteful to reach the celestial bodies above us. Apollo, the space shuttle, and contemporary SpaceX missions depend on chemical propellants. They consume enormous quantities of fuel merely to escape Earth's gravitational pull. Even accessing our nearest planetary neighbors remains extraordinarily challenging with chemical rockets. Researchers have investigated alternative approaches to accelerate space travel, including nuclear propulsion, ion drives, and even antimatter engines. Each presents potential, but each brings substantial obstacles. They demand excessive fuel, they lack adequate efficiency, or the science simply isn't mature enough to transport us to another stellar system. Proxima Centauri, our nearest star system, sits merely 4 light-years distant. But with current rocket technology, that separation might as well stretch to infinity. So if conventional rocket engines cannot deliver us there, then what solution remains? Among contemporary propulsion technologies, ion drives represent the most fuel-economical option. They utilize electricity to produce thrust, enabling spacecraft to accelerate continuously over extended periods. With adequate fuel reserves, an ion-propelled craft could ultimately attain remarkable velocities far surpassing what chemical rockets generate. But there's a complication. Xenon, the heavy gas necessary to produce the ions initially, exists in limited supply. We simply cannot transport sufficient quantities to accomplish the required acceleration across the vast distances separating stars. The Parker Solar Probe maintains the absolute speed record as humanity's fastest launched spacecraft, racing toward the sun at exceeding 690,000 kilometers per hour. But for spacecraft venturing outward into deep space, Voyager 1 continues as the fastest, moving away from the sun at approximately 61,000 kilometers per hour. At such velocity, arriving at Proxima Centauri would require more than 17,000 years. So, a probe launched today wouldn't deliver useful information for another 350 centuries. If rockets cannot transport us to the stars, then what alternative exists? The solution isn't additional fuel or more powerful engines. It's something fundamentally different, something requiring no fuel whatsoever, like sailboats driven by the sun. Could we accomplish the same with a spacecraft? Well, remarkably, we already have. The technology is termed a solar sail, propelled not by engines, but by the subtle pressure of light, the same manner a kite gets pushed by wind currents. The sun releases photons, minuscule particles possessing no mass, yet they transport both energy and momentum. This means they still apply force upon collision with a surface. When they impact a highly reflective solar sail, they don't merely disappear or scatter randomly. Rather, they transmit a portion of their momentum to the sail, advancing it forward one minuscule increment at a time. Unlike chemical rockets, solar sails don't consume fuel. Instead, they capture the perpetual stream of photons within sunlight. Though the initial thrust remains weak, it never ceases, and this uninterrupted acceleration enables the spacecraft to progressively attain extraordinary speeds over time, far exceeding what traditional engines could possibly achieve. Solar sails must be exceptionally lightweight, exceptionally durable and intensely reflective because absorption cannot produce thrust. Instead, it would merely warm the sail, squandering energy rather than transforming it into movement. Navigation functions by modifying the sail's orientation, similar to a sailboat tacking against the wind. So, light isn't merely the engine, it's the steering mechanism, the navigation system, and the fuel propelling the sail forward while providing it exact control over its trajectory. And this isn't science fiction. In May 2010, Japan's space agency JAXA successfully deployed Icaros, a solar sail spacecraft operating entirely independently without fuel. Icaros ultimately achieved a velocity of thousands of kilometers per hour. It passed Venus and maintained data transmission for 5 years. With a gravitational assist from Venus, Icaros eventually reached a maximum speed of 12,000 kilometers per hour. Given the opportunity, it could have ultimately traveled faster, even surpassing Voyager at 60,000 kilometers per hour. In June 2019, the Planetary Society's LightSail 2 utilized sunlight exclusively to modify its orbit around Earth, demonstrating controlled solar navigation actually functions. And in September 2024, NASA launched ACS-3, successfully deploying its 9-meter-wide solar sail. Its acceleration was minimal but detectable. However, one of the support booms has deformed, creating some complications. But the spacecraft persists in providing valuable data. These missions demonstrate solar sail's function, but to access the stars, sunlight independently might prove insufficient. We may need something additional, an extra boost. We can provide solar sails that supplementary push they require with powerful Earth-based lasers. Project Breakthrough Starshot, introduced in 2016 by Yuri Milner, Stephen Hawking and Mark Zuckerberg, seeks to accelerate solar sails to 20% of light speed, rapid enough to reach Proxima Centauri in merely 20 years instead of 350 centuries. The obstacle: cost. Constructing Starshot would probably demand billions of dollars. While we could simply utilize the sun to propel us, external lasers truly provide the critical difference. Space-based laser installations could function, but their output would never equal Earth-bound laser arrays, which can produce virtually limitless power. The concept is straightforward. Discharge a powerful laser at the sail and the photons drive it forward precisely like sunlight. But unlike the sun, a laser can focus tremendous energy onto a minuscule area, accelerating the sail far more rapidly than natural starlight ever could. The laser array itself must be massive, potentially kilometers wide, but it's not hazardous unless something like a bird or aircraft happens to traverse the beam. Since space is predominantly empty, there's minimal risk of damage beyond our atmosphere either. So, let's suppose we actually construct this vessel. Once a solar sail departs the solar system, navigation becomes considerably more challenging. Since light intensity decreases rapidly once you travel away from the source, the majority of the sail's acceleration must occur early, meaning accurate targeting is essential before entering deep space. Once a solar sail arrives at its destination system, decelerating is relatively straightforward in principle. By rotating the sail around to face away from the approaching photons of the new star, the identical light pressure that previously propelled it forward can function as a brake. But presuming that we can execute this correctly, that a solar sailing vessel can traverse the immense emptiness between our galaxy's stars, then what? What do we accomplish with that capability? Again, we can reference history. No sooner had it been demonstrated that a boat could sail westward across the Atlantic Ocean and discover new territories that a new epoch of exploration commenced. People are attracted to the unknown. It beckons to us, and inevitably humans will respond. But we must think ambitiously. A human-scale solar sail vessel would require an immense sail, kilometers wide, something that could exclusively be manufactured and constructed in space. The vessel itself would demand substantial radiation protection, and an absence of gravity throughout such an extended journey would present severe health hazards. Life support would need to be extraordinarily dependable and self-sustaining. If humans are participating, a purely solar-powered sail probably wouldn't suffice. Laser propulsion would almost definitely be necessary to achieve the required velocities. But the fundamental principle is valid. Solar sails demand no fuel, can attain incredible speeds, and could be our gateway to the stars. The sole obstacle preventing us is the determination to construct and fly them.